Okay. Before this, we all looking into linear line of sight. Now we look into angular momentum. Yeah. So angular momentum is, we define, let's say there's a plane body and you have x-axis, y-axis, and the z-axis. So we are looking at the rotation or the momentum at the z-axis. Here we follow the right-hand rules. We follow the right-hand rules. So if the object on the plane, xy plane, move in this direction with a d, then you curve your finger, the angular momentum will go up. Angular momentum will go up. This one will be like you're defining moment in your statics. What is moment? Moment, you refer to a reference point. Then the force must be perpendicular, and this is a distance. Moment will equal to force and distance. Right? So same with this one, angular momentum. You use your right hand rules. You follow your momentum, right? And the D. On the diagram, look carefully. The D is 90 degrees to your line of travel. If it's curved, then it's tangent. You draw tangent, you draw 90 degree, you get a distance. Okay. So for magnitude of your angular momentum, the magnitude, you take momentum, mv, times the distance. You take mv times the distance, you get the magnitude of your angular momentum. Okay. It's an equation for second half. How to find the magnitude of your angular momentum. You use right hand rules. You curve your finger depending on the momentum. Okay. The unit is m is kilogram, v is m stroke s, d is meter. So you have kilogram meter square over second. So if we change the diagram, let's say you have a vector that going on that direction with a path and the location r. So again, use your right hand rules. The moment is your fingers. So you curve your fingers, you get the direction of your angular momentum. The vector calculation is that you take the r position, cross the mv. Cross mv. It's a cross product. So if you don't know what is a vector cross product, go to appendix B or appendix C in your canvas. Right. So this to highlight that how to find if you're given R and MB vector. Okay. You know the vector when you have cross product, this is not dot product. Cross product, you need to include your matrix. I think you see this one in your, if you're civil, you see this one in your statics, structure analysis or something. All right. So when you cross, the first row here is your R or position. Bottom one is your momentum. And you write IJK. Right? I means for X direction, J for Y direction, K for Z direction. How to calculate this one? Go back to your mathematics textbook. How to calculate the magnitude of this vector. This is a 3 times 2 matrix. You need to recall chapter 2 equation, which is F equal to ma, all the force will create motion. In this case, all the force will create acceleration. And in referring to initial coordinate reference, your moment of the force, again, recall what is the definition of moment. You take the distance 90 degree times the forces, right? So in this case, you take R cross F. You always take position first, then cross the either momentum or force. In this case, we'll talk about moment. So moment is distance times force, cross force. Right, your cos is cross mv. F equal to m dot v dot is ma. F equal to ma. V dot is acceleration. You know that mass is a constant. You can pull it out in your cross product. So again, refer Appendix B how to do cross product. So you derive when you want to find the change of your momentum, you take this momentum, divide, integrate with time dt, right? You'll get r dot cross mv plus r dot r cross mv. This is a chain product, chain procedure, right? And okay, it's just mathematics. I will just go very fast. So what is important is that you can equal all the moment inside the system or equal to the angular momentum inside the system, the rate of change of your angular momentum inside the system. By looking at this one, is a new way of solving problems, dynamics problems, by looking at moment and angular momentum. Moment will equal to angular momentum. So you need, in your free body diagram, you need to consider the force and the 90-degree direction of your moment, and then the reference point to find the angular momentum. This one, Okay, so this is just an illustration of what happened when you study about rigid body later, right? Okay, let's look at how we apply this resultant of moment. Means all the moment inside the system will equal to the rate of change of your angular momentum. Again, you look at the diagram. This diagram slide from a curved body with the r and the velocity at this direction with the theta. You look at the direction, the diagram. Again, this is a collinear motion. We have collinear motion, draw normal and tangent in the free body diagram, and then input the mass. In this case, the box is sliding, so they must have a W inside your free body diagram. And when there's a contact, there's a normal force and a friction force. So in this case, you are being told there's a smooth surface. This is theta, typo error. At the angle theta has a velocity v. Determine the angular momentum of about point O at this instant and rate of change, rate of increase in its speed with its acceleration. Another way of saying acceleration is the rate of increase in its speed. It means acceleration. Okay, sometimes the question was not direct. It will not tell you to find acceleration. It will mention something, this phrase, the rate of increase in its speed. It means ask you to find acceleration. Okay, free body diagram. You look at the diagram, you draw normal and tangent. because you have a curved surface. And then you draw the reference point O. R or normal will always pointing to the center of the curve. You have an angle and you have a weight pointing down. You have a normal because there's always a contact surface. No friction because the question already asks you to already mention smooth. But of course, in assessment, it will not be that easy. You will see constant of friction is given, right? So there's a friction force there if the friction is given. So in this case, your V is tangent to the curve. V is tangent to the curve. So the angular momentum, what is angular momentum? You take momentum times the distance, which is 90 degree. In this case, it will give you the R, which is 90 degree, to the velocity of your object. Your V is in this direction, tangent direction. So your V times 90 degree of the distance, MV cross R cross MV. Okay, so R cross MV, R cross MV, you get anti-clockwise direction. This direction, make sure you use right-hand rules. You need to mention this one in your answer if this one come out in your assessment later. Okay, always have give direction. Okay, R cross your V. So acceleration, to find the acceleration, you use the momentum, sum of momentum equal to angular momentum, the rate of change of your angular momentum. So left-hand side, how to form momentum or moment? You take mg or moment. Moment on the left is F times d. Here you only have one force, W. You split this one to T direction and N direction. T direction will give you moment, but the R direction do not give you moment because the distance is 0. R is 0. Okay? Right? So for example, this is the basic fundamental definition of moment. You take force times D. When the force is going along the D, let's say this is D, this is reference point. There's no cross product there. So there's no moment created. Moment 0. If it go along the reference parallel to the D, then no moment. Okay. Moment must have a 90-degree relationship between the distance and the force. In this case, you're talking about moment on the left. You only seen W. And if the question in example 9, we remove the smooth and give you the friction coefficient. Friction coefficient is negative. This way, it will create moment on the left-hand side equation. Okay, in this case, smooth, so no friction. Okay, friction will be opposite direction, but same distance R, but with the friction force negative. Then left-hand side is the change of your angular momentum, dt, R, mv. So momentum times the R is your h, right, dt. R constant, m constant. You can rewrite the equation. This one pull out. You write equal to A. This is your acceleration. And you can cancel M. Cancel M. Cancel R. So you'll get G sine theta equal to dv dt. Then you use chapter 2 collinear motion, F equal to ma, in this case tangent direction. Still the same, ma, you only see all the force in tangent direction only. Normal do not contribute to tangent direction. So W split to tangent direction, you get sine theta. MAT, you still derive the AT into dV dt. Cancel M, right? You still get the same answer. This is by using chapter 2 approach. Just now is using this one, moment equal to change of your angular momentum. Okay. Yeah, for your second test or final exam, you'll be told to use this approach. Okay. And prove that your answer with F equal to m. Okay, by using this approach. So there are two methods. One is the chapter 4 approach, and chapter 2 approach, F equal to m. You still get the same answer. Okay. How you know you need to use angular momentum equation? The question, you will see angular momentum there. It means we want you to use this equation. Okay. So before this, you have principle of linear impulse and momentum. Here you learn about angular impulse and momentum. So you have principle of angular impulse and momentum. You rewrite the equation. Just now, the left-hand side is moment, right-hand side is a change of your angular momentum, rate of change of your angular momentum, m dot, h dot. So you rearrange this one into differentiate of dt. Then you move the dt to the left. You see dt, you can integrate, right? You see dt in the equation, you can integrate. So when you integrate, you get the momentum, not momentum, the angular impulse. This is called angular impulse. Again, impulse, you only take something related to time, right? Linear impulse, you take force. Angular impulse, you take moment. Yeah. Linear impulse, you take integrate force times time. But angular impulse, you integrate moment dt. This is the difference between linear and angular. Huh? Okay. So when you continue deriving, you'll get the same structure, which is the momentum, angular momentum, before will equal to angular impulse equal to angular momentum after. Okay. Here you learn something new, the angular momentum, h. It is your r cross your mv, cross products, and right hand rules. You always take r cross your mv. Okay. So you break your m into r cross f. Moment is force times distance. In this case, you take r cross f. The rest is just derivation. So sometimes it's not direct to find the angular moment. You need to find r cross f. So go and polish up the vector cross product. Okay, so vector you can split into x, y, z like previously. You have one set, then split the principle of angular impulse and angular momentum. So in short, we just use principle of angular impulse and momentum. Momentum here actually linked to angular. It's not the linear momentum. is a one set, angular impulse and angular momentum. So you can split into x, y, z, as you can see on the slide here. Okay, here you have the first one, the MV1 you can split, and then H1 you have one set. H1 you have one set. Huh? So in total, you can split into 4 equations. This one cannot split into x, y, z. There's no x, y, z there. Only moment or momentum have x, y, z. Okay. So when it comes to chapter 4, when you deal with angular momentum, this 4 is very popular. Normally, when you split this one, you need to write this 3 and then add one more 4. You have 4 unknown to solve. Okay. Okay, the rest you read, and then same, you come with the conservation of angular momentum. You cancel the momentum, you'll get H1 before to equal to H2, which is you conserve your angular momentum. Again, what is H? Distance cross your momentum. R cross MV. Okay, let's see how we apply the principle of angular momentum and impulse and the conservation of momentum, angular momentum. We are giving a curve. So you know this is a curvature motion. You have to identify either this one is linear or rectilinear or curvature. This is very direct. This is a curvature motion. Straight away go to the object, draw normal tangent axis. Then continue, write where is your acceleration in tangent, normal, and then write the acceleration normal, v square over rho, and v a equal to dv dt. Then you start solving. So mass is given, and the force is in the function of t, f equal to 150 t square. So here, if you're given a variable of your f, you need to be good in your integration. Determine the speed of car at 5 seconds. The car initially travel at the speed of something, ignore the size of the car. So you draw free body diagram. So in this case, I draw in 3D because you are dealing with angular momentum and angular impulse. You need 3-dimensional free body diagram. A bit different from the linear free body diagram. Here you have Z, R, and the curve. The curve here. So I just this is a curve. So on the car you have normal and weight pointing down. Okay, Z here. This is the XY plane, and this is a curve. This is a curve. So the car is the tangent is moving upward like that. Right, tangent normal pointing in. So there's a force given. If the traction force of the wheel on the road is F. So you have force and the R direction. R direction. So you use principle of angular impulse and momentum. You have normal force and radial force. So this is a normal force. This is this is the tangent force. Right, tangent force or radial force. Right. Then you break the equation according to the scenario. This is the principle of angular impulse and momentum equation. H equal to integrate m dt h. You change the 0, 1 into z axis. Same with the momentum, refer to the z. Then you start to substituting the value. What is angular momentum? You take r times the mv in tangent direction, r times your momentum, right, mv, plus the impulse is your r times your force. This is the moment, right? What is moment? Moment is r times force. So you get rf dt and the angular momentum on the right. Then you substitute, right? Substitute. You can calculate the angular momentum. But r 100, m given, v given, right? So before you're given the velocity, but after you don't know. So there's one unknown there. You don't know something on the right. Then you integrate the angular impulse, put inside the value, r is 100, f dt, so you have to be good in integration. Huh? You integrate with time, so this one becomes 3 divided by t power 3 divided by 3. You get your v value. Okay, this is how you work lah. Principle of this one, right? I skip a lot of mathematics calculation. You try to observe how we solve. Huh? Important is, do you know how to draw the free body diagram in 3 axes, especially when they link to angular impulse and momentum? Okay. This is a tutorial question again. It will be very simple. Huh? It will be very simple. It will, and we are now in chapter 4. So when it comes to your assessment, it will be a lot of more information will be given. Right? So example 11, same. You see x, y, z normally it fall under angular moment and angular moment, angular impulse and momentum. So you have given an object I to origin here, and this one, the origin here is elastic cord, so this one can be longer one. It can be stretched one. You are given the k value there. Initially unstretched. If the disk given a velocity so and so 1.5 perpendicular to the cord, determine the rate at which the cord being stretched and the speed of the disk at the instant cord is stretched at 0.2 meter. This is stretchable. So you need to find when this rod stretch 0.2 meter, and you need to find the speed of this one. So given z, given y, given x, so this one spin this way. So draw free body diagram, copy the axis, right? Then put in the distance that is important. In this case, you know, you tie to something. When you run, you will move in a curvature motion. Right? Curve motion, distance 0.5. This is the initial one. So velocity always tangent to the curve. So let's say this is a second direction, a second position. So we reach here and then stop here. Here, I break my velocity when it reach distance 2 at what the question want you to find. Huh? So 0.5 stretch 0.2 means this is early direction, early position, end position. And at the end position, you know this is a collinear motion. There's a tangent direction. You split the velocity into 2 directions. Right? One is along the radial, one is to another direction. Then there's a weight pointing down because it's a 3-dimensional question. Pointing down. It gives you smooth surface, so there's no friction. Okay, now start when you do revision for your assessment in test 2 or final exam, make a remark, for example, 10 or 11. This is a smooth. Start to think what happened if there is a friction given, how you solve. Make a remark there. Huh? Try to think, if this case is not smooth and there's a friction there, how do I solve this question? Okay, make a remark there. Huh? All right, then you have contact surface, normal force, weight, and the force of the cord that is pulling in. Why the arrow pulling in? You imagine you are the body again. You tie to an elastic rope. You being spin. What do you feel? Something pull you, right? When you turn and then there's an elastic cord, something pulling you out, right? So the force is pointing into the center. Okay. Once of that, you have a free body diagram. Use conservation of angular moment. Start observing that what scenario we use conservation. We use conservation, we always look at the big picture. We also want to find what happened before and what happened after. We don't deal with the middle process. Okay, in this case, we deal with what happened after before and what happened after. So conservation of angular momentum is h before equal to h after. What is h? R cross mv. R cross mv. So R is this one. R1, R2 is this one. And you only have one object, so mass is the same, but velocity is different. Velocity 1 and 2 is different. Okay, recall what is definition of angular momentum? R cross mv. So you put in all the value. R you know, R1 you know, MD you know, VD you know, position 1 you know. You only have one missing parameter. Here you're able to find velocity number 2. Again, try to observe what conservation of momentum can give you. It always give you velocity. Okay, and you look at the big picture rather than focus on that tiny one. Okay, you have V2, then you start to use conservation of energy. Why suddenly you need to pull energy? Because this is an elastic case. You have an elastic and it's a velocity and else, yeah. So you have kinetic and potential energy. Right? You put in there. In this case, you are moving on the same plane, so mgh 0. But remember, in this case, the cord is elastic. It's like a spring. Spring energy is half kx squared. Force of the spring is F spring. Force spring equal to kx. But energy of spring will equal to half kx squared. That's why in this case, you are seeing kx squared there. Before equal to after energy. You substitute the value. There's one missing, which is d. Velocity at second station is missing. You substitute, you find that. So how many conservation of law you have? The conservation of energy, conservation of momentum, conservation of angular momentum. So you need to look at the question. The question, if there is no other things that you can use, you just recall what equation you have. When you conserve something means you only look at before and after. This one. Okay, so yeah, okay. This is the resultant, right? The resultant you can split into radial and angular change. It's the angular change. Means the change of theta in the theta direction. Okay. Then D2 prime trigonometry, you have resultant, you have tangent direction, and you have an angle direction. So you have two, you find this one. Okay, so this one square equal to this one plus this one. So this one missing, this one missing. So you take minus. Substitute, you get the second one. Okay, this is how you solve question 4. 4.8, float stream. You take float dynamics, you take hydraulic, something, right? Okay, hydrostatic. This is on the hydrostatic or things that deal with the flow stream. I will not test you in this one. Okay, but this is for your information. You are taking civil and pure mechanical, so this one is important when it comes to flow. Anything deal with water, okay, or things that can move. My major is in aerospace, so I deal with nozzle, gas, and so on. So this one also important when we try to solve nozzle design or chamber design, channel design, and so on. So this is using principle on force and momentum. Here, you only need to focus on the volume. Volume go in, or momentum go in, or impulse at point A. When it come out, the energy must same. The concept is there. So you read the slides. Before plus, you see this one? This one is momentum. This one is impulse. Angular momentum, angular impulse, angular momentum. Same. All right. So you have the mv, you get momentum. Then after it come out, also change of mass times velocity, also momentum. What happened to the impulse in the center of the process is force times the distance. Okay. So when you use this diagram, when you want to focus on that individual object, okay, normally when you use conservation, you only focus on before and after. Then you look at energy before and after. Then if you're still missing parameter, you focus on this one. Okay, the rest you read. This one you read. All the information is there. Okay, it's very complex. You read. It deal with mass flow, rate. Go on. So far, I won't test you. So you need to recall dm dt, mass flow rate. Dm dt, how to find mass? Density times volume, you get mass. Times area, you get mass, right? Rho times velocity times area, you get dm dt. Right? Rho times velocity times area. This one times this one, you get volume. Then this one is velocity. Then you get mass. Right? Then this one you learn in your hydraulic in your hydraulic. So Q equal to VA. This is normal. Normally you will see Q equal to V times cross section A. The pipe cross section. When you deal with hydraulic. Again, in this module, I do not focus on this one. Right? So some example like this. You only need to focus on this formula. Before equal to after. Okay? Draw free body diagram, so and so, you read. You find free body diagram, find a moment. Find a moment, equation steady flow. Okay, then you find T and so on. Okay, this one read your homework. Read. Okay. Read. Okay, with this we conclude chapter 4.